Chapter 1, Section 9, Digging Deeper, Volcanoes in the Atmosphere, Hazards of Volcanic Ash. In the Investigate, you analyzed volcanic eruption data. Geoscientists use specific names for the materials erupted from a volcano. Tephra is a term for pieces of volcanic rock and lava that are ejected into the air. Tephra is classified by size. It ranges from less than a tenth of a millimeter to more than 1 meter in diameter. So that's a really big range. So tephra is a term for pieces of volcanic rock and lava that are ejected into the air. Tephra is classified by size. It ranges from less than a tenth of a millimeter to more than 1 meter in diameter. Names for sizes of tephra include volcanic bombs, which are greater than 64 millimeters, lapilli, which are between 2 and 64 millimeters, and ash, which is less than 2 millimeters. Bombs and lapilli usually fall to the ground on or near the volcano. Ash can travel hundreds to thousands of kilometers. See Figure 1. So this shows, Figure 1 shows that ballistic debris refers to volcanic bombs and lapilli that can fall on or near the volcano, and ash can travel much further. Okay, so the height of the ash and the wind speed control how far the ash travels. Volcanic ash presents many kinds of hazards. Ash that falls on homes, factories, and schools can collapse roofs. Just a single cubic meter of volcanic glass shards can weigh 2,450 kilograms. More than 800 people died after the 1991 eruption of Pinatubo in the Philippines. Most of these deaths were caused by roof collapse. At ground level, fine ash can cover and destroy crops and make the treatment of river water difficult. Particles of volcanic ash have sharp edges and can cause breathing problems in humans and animals. In Figure 2, it shows a huge pyroclastic flow from an eruption in Alaska. Let me scroll up so you can see the whole thing. And that's actually not the whole thing because, as they say, the ash can travel very far. Okay, so scroll back down. Wow, look at that. 1 millimeter ash particle from Mount St. Helens. You don't want that in your lungs. All right. It can also damage automobile and truck engines. Ash that coats the leaves of plants interferes with photosynthesis. Ashfall accumulations of only a few millimeters can be a significant hazard to airports. Between 1944 and 2006, 101 airports in 28 countries were impacted 171 times by eruptions at 46 volcanoes. Since 1980, volcanic eruptions have affected an average of 5 airports per year. In 2011, Grímsvötn, Iceland's most active volcano, erupted. It spewed ash nearly 20 kilometers or 12 miles into the atmosphere. Nearly 900 commercial flights were canceled across Europe, leaving passengers stranded at airports. Ash injected high into the atmosphere can also damage aircraft. Since 1973, more than 100 aircraft have been affected by volcanic ash while flying. The only death outside the immediate area of Mount St. Helens occurred from the crash of a small plane that was flying through the ash. Ash that falls on the slopes of a volcano poses a great risk. When soaked in rain, loose ash can form lahars. Years after the eruption, lahars remain a source of concern to communities at the base of Pinatubo. Okay, this is what a volcanic bomb looks like. Volcanic gases. In the Investigate, you developed a model that illustrated the release of gases from a volcano. Gases that escape in the greatest amount from volcanoes are water vapor, carbon dioxide, and hydrogen chloride, and nitrogen. These and certain other gases play an important role in the Earth system. They have been important over the long span of geologic time. They continue to be important at the present time. Am I in the right spot? Okay. Early in Earth's history, as its interior cooled, volcanoes released a lot of carbon dioxide into the atmosphere. However, there was no oxygen. Partway through Earth's history, primitive algae appeared. Over millions of years, through photosynthesis, they shifted the balance from a carbon dioxide-rich atmosphere to one with abundant oxygen. Carbon dioxide is more dense than air. It can sometimes collect in a low spot near a volcanic eruption. It is also a colorless and odorless gas. High concentrations of carbon dioxide are hazardous. It can cause people and animals to suffocate. Volcanoes release large amounts of water vapor. Much of Earth's surface water seems to have been released from Earth's interior by volcanoes throughout Earth's history. Water vapor is an essential part of Earth. It is especially important for human communities because it sustains life. When you think of the water cycle, do you think of volcanoes? Some volcanoes emit large amounts of sulfur dioxide gas. This gas is colorless but has an odor. It can be irritating to the eyes, skin, nose, and throat. It can cause health problems in populations that live downwind of volcanoes. In addition, sulfur dioxide combines with water vapor and oxygen to form sulfuric acid. The sulfuric acid is washed out of the atmosphere by rain. This occurs over large areas downwind of the eruption. Rain that contains sulfuric acid and certain other acids as well is called acid rain. It is produced not only by volcanoes, but also by power plants that burn coal containing sulfur. Acid rain damages plants both on land and in lakes. Danger, CO2, danger, carbon dioxide hazard area ahead. Figure 5 shows a warning sign by the shores of Horseshoe Lake located in California's Lassen Volcanic National Park. Every day, 100 tons of CO2 are released through the soil from an underground volcano. Volcanoes and climate change. How do volcanoes affect climate? If the Earth system were simple, answering that question might be easy. Suppose that volcanic activity is the independent variable. This is the variable that, when changed, causes a change in something else. The something else is the dependent variable. In a simple model, climate would be the dependent variable. Temperature is an aspect of climate that can be measured. You could plot the volcanic activity over time against temperature. You could then compare the volcanic activity, which is the independent variable, to temperature, the dependent variable. You could use the graph to make inferences about the effects of eruptions on climate. However, the Earth system is complex. Records of climate and volcanic activity are imperfect. Some volcanic products should warm the atmosphere. These include carbon dioxide, a greenhouse gas. Others should cool the climate. For example, microscopic particles of volcanic ash in the atmosphere block incoming sunlight. Because climate is controlled by many factors, modeling and understanding climate change is complicated. However, evidence suggests that major volcanic eruptions can lower the average temperature of Earth's surface by a few tenths of a degree Celsius for as long as a few years. It is often thought that volcanic It is often thought that volcanic eruptions increase or cause rainfall near or downwind of the eruption. Volcanoes eject very fine volcanic ash into the atmosphere. Water droplets and clouds form around these small particles. Eruptions can also heat the local atmosphere. This should increase convection or circulation of the atmosphere. Finally, some volcanic eruptions release great quantities of water vapor. Water vapor is needed to form clouds and rain. However, a number of studies show that an increase in rainfall is rare after an eruption. The major eruption of Krakatoa in 1883 did not increase rainfall. It occurred during the wet monsoon season. It seems that there have to be certain conditions in the atmosphere near a volcanic eruption for rainfall to increase just because of the eruption. A volcanic eruption can put huge amounts of sulfur dioxide gas all the way into the stratosphere. The gas then slowly reacts with water. It forms tiny droplets of sulfuric acid. The droplets are less than a thousandth of a millimeter in diameter. Unlike in the troposphere, these sulfur dioxide droplets are not affected by the water cycle. The droplets of acid stay suspended in the stratosphere for as long as a few years. Large quantities of very fine volcanic ash particles can also reach the stratosphere during major volcanic eruptions. Along with the acid droplets, they reflect sunlight. Scientists think that this may cause global cooling that is often observed for a few years after a major volcanic eruption. For example, following the 1815 eruption of Tambora in Indonesia, many areas in the United States and Canada had unusually cold summer weather.